Welcome to variation of parameters. So recall in the previous videos, if we had y prime plus p of x, y equaling, I'm going to change this to g of x here instead of q of x. If we have this type of differential equation, this has general solution y equals u times y1, where y1 is a solution to y prime plus p of x times y equals 0. And u is a solution to u prime equals g of x over y1. Technically, you could jump straight to the integral formula for u if you want, but that's more or less what I have there. So if we want to find the general solution to y prime plus 2ty equals e to the 3t times 2t plus 3. We first need to solve, so e to the 3t times 2t plus 3, this is acting as our g of t, plus 2t is our p of t. So the first thing we need to do is we need to find y1. So we are solving the equation essentially y1 prime plus 2t y1 is equal to 0. And recall that this had the final solution, y1 is equal to e to the negative integral of 2t dt. Again, that came from rearranging the formula to y1 prime over y1 is equal to negative 2t. Integrating both sides, you would have natural log of the absolute value of y1 is equal to the negative integral of 2t. And then we could do e to the on both sides. We don't need the c in this case because we just need one y1. So what we have here then is y1 is equal to e to the negative t squared. Again, we don't need c. So we don't need to include c since we just need one solution. Once we have our y1, then we can go ahead and solve for our u. So we're going to have find a y equaling u times y1 such that y prime plus 2ty is equal to e to the 3t times 2t plus 3. So from here, again, recall that what we get from here is that u prime has to equal our g of t, so e to the 3t times 2t plus 3 divided by our y1, or e to the negative t squared. One moment, my screen is not updating. Right, so this top part here was our g of t. And then down below, we'll need y1. So our y1 is e to the negative t squared. And rearranging this is u prime as equal to e to the t squared plus 3t times 2t plus 3. So at this point, we can go ahead and do our integration. So we have that u must be equal to the integral of e to the t squared plus 3t times 2t plus 3 dt. I need to give myself a little more room. This winds up perfectly being a u substitution problem, except since we already have a u involved, I would use something other than u. So we could set x equal, let's set x equals t squared plus 3t. Then we have that dx is 2t plus 3 dt. So this integral in terms of x, we're just looking at the integral of e to the x dx, or e to the x plus c. Going back into t's, we have u is equal to e to the t squared plus 3t plus c. So our final solution we know that y is equal to u times y1. So we have y is equal to e to the t squared plus 3t plus c times e to the negative t squared, otherwise known as e to the 3t plus c e to the negative t squared. So again, I sort of didn't jump straight into the formulas where you go straight to the integral. I sort of did a middle formula. I find it easier to remember the u prime equals g of t over y1 as opposed to u is the integral, even though they're basically the same thing. I also sometimes for solving for y1, we'll start off at y prime over y equals negative p of t. That's up to you where you want to start sort of in the formulas. So from here, let's go ahead and do one more example. This time around, we're going to do an initial value problem. So IVP is initial value problem. We have y prime minus 5y is equal to cosine of 2t. So our p of t is just negative 5. Cosine of 2t is giving us our g of t. So we are going to go ahead and start by finding the general solution to this equation, and then find the initial condition. So the first thing we need to do is we need to find y1 such that y1 prime minus 5y1 is equal to 0. This was one of our more straightforward solutions. You could jump straight to the answer, or you can sort of go somewhere in between. So here we have y1 is equal to e to the negative integral of negative 5 dt, or e to the integral of 5 dt. And we get that y1 is e to the 5t. Again, we don't need to include c, since we just need one solution at this point. Now we're going to find y equaling u times y1. So that y prime minus 5y is equal to cosine of 2t. So again, what we have at this point, we know that u prime is equal to g of t over y1. So u prime is cosine of 2t divided by e to the 5t, or u prime is e to the negative 5t cosine of 2t. So from here, again, we have u is equal to the integral of e to the negative 5t cosine of 2t dt. We're going to have to do a little bit of our integration by parts here. Neither cosine nor e to the will go to 0. So this is a case where we're going to look for another copy of e to the negative 5t cosine 2t to pop up in an integral. So I'm going to stick with u dv, but this time around, my u is no longer that entire piece. I'm going to take cosine of 2t as my u, and e to the negative 5t dt as my dv. Doing our differentiation down the side, we have derivative of cosine is negative sine, and then chain rule, we'd have a negative 2 times sine of 2t. On the right, we would have negative 1/5 e to the negative 5t. The integral coming from that involves sine. That's not useful. Let's go one more time. Taking the derivative on the left side, we would have negative 4 cosine of 2t. And on the right, we will have 1/25 e to the negative 5t as we integrate. Let me update my screen once again. All right, so there's what I was writing that my screen wasn't reading. At this point, we have our multiply on the diagonal, multiply on the diagonal. The first one will take the positive, next we'll take the negative, then opposite sign, and so we're back to positive and integration. So again, notice I have my cosine 2t e to the negative 5t in an integral, which is what I had started with. So at this point, we have the integral of e to the negative 5t cosine of 2t dt. That's our u. This is equal to negative 1/5 e to the negative 5t cosine of 2t. Then we will have minus a negative, becomes plus 2/25 e to the negative 5t sine of 2t. And then we have plus the integral, so we'll have minus 4/25 times the integral of e to the negative 5t cosine of 2t dt. Now keep in mind that this integral is u in both places. So what we're really looking at is u is equal to negative 1/5 e to the negative 5t cosine of 2t plus 2/25 e to the negative 5t sine of 2t minus 4/25 u. So, and then we have a plus c somewhere in there we can tag in at the end. So if I add that to both sides, we are looking at 29/25 u is equal to we just have negative 1/5 e to the negative 5t cosine of 2t plus 2/25 e to the negative 5t sine of 2t. Multiplying through by that 25/29, we have that u is equal to negative 5/29 e to the negative 5t cosine of 2t plus 58. Oops, sorry, not 58, 2/29. Flipped my fraction there. 2/29 e to the negative 5t sine of 2t. And then we should have a plus c. So our solution, our general solution, is y is equal to u times y1. So we have y is equal to, our y1 was e to the 5t. Then we are going to multiply by our u, so negative 5/29 e to the negative 5t cosine of 2t plus 2/29 e to the negative 5t sine of 2t plus c. And multiplying that in, we get that y is equal to negative 5/29 cosine of 2t plus 2/29 sine of 2t plus c e to the 5t. From here, we just have our initial condition. So now we're going to do our particular solution. Our initial condition was that y of 0 is equal to negative 1. So scrolling back down, we have y of 0 equals negative 1. So we have y is equal to negative 5/29 times cosine of 0 plus 2/29 times sine of 0 plus c times e to the 0 is equal to negative 1. Or I'm going to just write y of 0 out front in a moment. This was y of 0 equals that. So this becomes negative 5/29. Cosine of 0 is 1. Sine of 0 is 0, so that next term disappears. E to the 0th is 1, so we have negative 5/29 plus c is equal to negative 1. We therefore get that c is equal to negative 24/29. And so our solution would be y is equal to negative 5/29 cosine of 2t plus 2/29 sine of 2t minus 24/29 times e to the 5t. So there is our particular solution. You can always check your solution by simply plugging it back into the differential equation and into the initial condition and verifying that it does check out. But this is sort of the process for solving this non-homogeneous linear first order differential equation.